Okay, so for today, we have Mastering Manipulatives with Sara Delano Moore and Kim Rimbey. They are co-authors, like as I just said, of that series of books, Mastering Manipulatives. Just a little background on these two women. Sara, she is currently the Vice President for Content and Research at Origo Education. She's been a classroom teacher, a mathematics teacher, educator, and I think you'll hear today her one of the things she emphasizes is connecting multiple representations. And boy, my computer is acting strangely today. Sorry.
No, I just
And
changed
then,
the screen share.
okay, sorry. And then we have Kimberly Rimbey. She was formerly the director of mathematics for a district, I believe, in Arizona. She is currently the chief learning officer and CEO for her own company, KP Mathematics. And I got to tell you, they have a very, very cool manipulative on that site. And she is very passionate about making mathematics meaningful for students through the use of multiple representation as well. So, with that, I am going to turn it over to Sara and Kimberly. And thank you so much.
That's great. Thanks, Mark and friends. We had a minor technical challenge, so Kim and I don't have the same name, but it's all good. We're certainly happy to be here, as always, to talk about how do we teach with manipulatives, to think about how do we push students to make these genuine tools for understanding the math, not just acting it out in a repetitive way with the teacher the same way we might on paper. It's a little more engaging, but it's not nearly as learning focused. And that's what Kim and I've been thinking a lot about over the years, much of our careers in different ways. And it's been fun to come together and do this work with these books. We want to talk about three things today. I'm going to start briefly with the idea of connecting representations and why that's so important. And then I'm going to share with you some strategies that we've developed over our collaboration for helping students and teachers make those connections. The bulk of the session is going to be 4 examples of what that looks like. We tried to span those across the grade ranges so that you can see ideas that relate to the mathematics that you're teaching, no matter what level you are. And then because it frightens me that tomorrow's August 1st and the school year is beginning, for some folks may have already started. And we're going to end with some practical tips. How do we help students and teachers use these tools thoughtfully and use them well? I think that's one of the hardest things about teaching with manipulatives is simply becoming comfortable with there's all this stuff and there's all this activity, and depending on the tools, there's all this noise. There are all these tabs open on the screen if you're working in a virtual space. It's a lot. And so we want to remind you, refresh for you, here's some good ways to get started. So with that, I'll begin. Kim will chime in this first part as she has things to add, and please stay active in the chat as well. We always love to hear your thoughts and share your wisdom with the group. So one of the things NCTM talks about as an effective teaching practice for mathematics is this notion of using and connecting multiple representations. And the research team put together this model that we often see in some form or another when we're talking about manipulatives. If you look at the arc across the top from concrete at 9 o'clock to visual or pictorial or semi-concrete or representations, which is not a great word, but it works, to symbolic at 3 o'clock, that's the Piagetian sort of classic CRA, CPA. When you think about child development, whether it's Piaget or Bruner or whoever it might be, kids learn with concrete things, then they become more abstract by creating sketches or pictures or drawings or whatever image it might be. And then and only then do the symbols really make sense. The example I like to use is that many years ago, 30 years ago now, give or take, I took a group of seventh and eighth graders along with a teacher colleague and some parents to what was then still the Soviet Union. And we were tourists in Moscow for a few days, and then we flew to Kiev and spent a week with families there, going to school and just getting to know the place. We spent time before the trip learning a little bit of Russian, but Russian's based on a Cyrillic alphabet. So I got to tell you, for me, I don't think I learned the language. I memorized what some squiggles looked like so that I wasn't sending a 14-year-old boy into the women's restroom or things like that. This was my teacher paranoia at that point in time. For a lot of kids, the symbolic part of math is like that. It squiggles on the page that if I can memorize well, I know what to do with. And if I can't, oh well. And the way we give the meaning, the symbols, is by connecting to concrete tools, physical manipulatives, visual tools like sketches and drawings. I think the virtual tools we're working with today kind of bounce somewhere between those two. We were talking before the session started, and one of the great advantages of virtual fraction tools is you have an endless supply if you're counting by unit fractions. But it's not quite as concrete as I can touch it. So they live in that in-between space. The important thing to remember about this model, though, is those are not the only three representations on it. There's also down at 7 o'clock context. So when I'm at the grocery store and keeping my running approximate tally of my list, what my bill's going to be as I shop, then that's context. And what's going on that I need to add, and why do I round up? Because for everything, well, because sales tax is charged on some things and not others, and I don't want to worry about that much, and because sales tax isn't built into American prices. So that helps me do that. The context gives me some meaning and some work around it. And then the verbal, simply, how do we say x squared? The x with an exponent of 2 next to it. Some people will say x2. I've heard students say x little 2, knowing that that's how you say it. Or when we type quickly and use the letter x for multiplication, say we're working on the dimensions of a solid figure that is 3 by 4 by 5. That's not 3x, 4x, 5. It's read 3 by 4 by 5. That's the verbal part, and that's really critical to kids' comfort and confidence with the math. You can make any of these connections. And the learning comes, what I've always said about this is the learning is in between. It's the arrows where we're looking at one representation to another. That is where kids actually learn, because that's where they have to take the basic things they know about this manipulative and translate them to a different representation. And while our end goal for much of mathematics is the symbolic, it's not fair to expect kids to make sense of the symbolic without context, without pictures, without objects. We have to do that. And so what Kim and I've done in our work is really anchor it in 6 different strategies that we can use to help students and teachers make these connections. The first is make a sketch. So you've taken base 10 blocks and you've built this model of an addition problem or a subtraction problem. Draw a picture of it. This is the moment when you say it's fine to use a line segment for the rod. You don't have to actually draw a 3-dimensional image. You don't have to get all the partitions in to show the 10 units. Just draw it. But make a sketch of what you're doing. If you've drawn a picture, write a caption. That caption might be context. The farmer had 3 pigs and then one of the pigs had 5 piglets. So now how many pigs are there? That caption might be more mathematical. The sum of 3 and 5 is, or that kind of thing, but create a caption. Name your model. Those two aren't that different, but captions tend to be more narratives and name tends to be more efficient. Create a diagram, build an equation, write a word problem. It's these last two that we're going to focus on today in this session as the strategies we talk about. And I want to pull the chat window up while I'm here. Thank you, Kim. Chiming in on lots of things. So let's start with build the equation. This is a strategy where we're asking students to connect symbolic representations, the equation or the formula. The example I'm going to give you first is about the formula for finding the mean or the average of a group of numbers. We talk about that as add them all up and divide by, or the sum of divided by the number of, depending on what age the kids are and what notation you're using. But what does that look like with concrete objects? And then Kim's going to give you an example with number sentences for that same strategy. So let me switch myself over to Brainingcamp, and Mark and the team are going to pop out the share code for this so that if you want to follow along, you can. If you want to just watch me for right now, let me make this a little bit bigger. That's fine too. So the formula for mean, kind of in the middle of my screen, is the sum of the values divided by the number of values. It's not quite as clean as volume equals length times width times height, but it's that same idea. And I put this in a context. 4 friends were at the beach and they collected some shells. We've got a little chart there for how many shells each one found, about how many shells were found per person, or on average, how many shells did each friend find? That's what we're thinking about here. And I could say just 5 and 8 is 13, and 3 and 7 is 10. So that's 23 divided by 4. That's not friendly. If I were in a classroom with you all in person, I'd have Jane and Pete and Madison and Charlie standing up at the front of the room. Each one would have some cubes. And I'd pass around a bucket and we'd dump all the cubes in the bucket. That's the add them all up part. And then we'd pass the bucket. Take one, take one, take one, take one. That's the divide by 4 in this case. And we'd literally act it out with physical objects. Virtually, here's what we can think about. To save us a little bit of time today, I went ahead and created this bar graph representing everybody's shells. And if you think about what I just said, the sum of the values is this collection of cubes, tiles, because each one represents one shell that was found. I have to create 4 equal groups because what I'm doing is smoothing it out, spreading it out. And so I can look at it and say, okay, there's 1, there's 2, there's 3. Oh, that one needs another one. Let me drag that down there. This one needs 1. Let me do that. That needs 1. Almost 6. Because everybody's got 5 and then 3 people have 6. So my mean, my average in that sense, is almost 6. And this is what would happen if we were passing around with physical cubes as well. 3 people would have 6 cubes and 1 person would have 5 cubes. Depending on where your students are, this is a topic in the curriculum that shows up at different points in time, depending on the state you're in. You may or may not want to go down the fraction road or how you think about what to do with that missing part. I'm going to keep it very high level today and say it's almost 6 or somewhere between 5 and 6. That's an understanding of what the formula for mean actually means. I take these bunch of objects, because it's a very deliberate example to have seashells here, not grades on a test, because we can touch them. If you can choose something that you actually have and work with actual seashells or cookies or whatever the thing might be, that's even better. It helps students understand what's going on when I say the sum of the values. That's dump it all in a bucket. That's outline it all on the chart. And then divide it by the number of values means spread it out evenly. Even though in this case, Madison didn't find nearly as many as Charlie and Jane, but if it were even, everybody'd have picked up 5 or 6 shells. And in a lot of cases, when we need an average or a mean, that information's enough because the fractional part doesn't necessarily make sense. Is 3/4 of a shell a broken shell? It's like saying the average American family has 2.6 children or whatever. I don't know what the current number is. What is 6/10 of a child? You've really got to understand that what that means is I've got 10 here, 10 rows, and 6 of them have 3 and 4 of them have 2, if that's the number. And this gives that visual, really concrete sense of what's going on with this calculation. With that, I'm going to stop sharing for a moment and hand it over to Kim to talk about this build the equation idea in another context.
And so even though my box here says Sarah, this is Kim. And we're going to talk about this in a context now that is in a more primary setting, although some of you who work in upper grades will also find some relevance with this one. So this one, if I was working with little students, we might tell this story verbally as opposed to having it in writing. But right now I have it in writing just for the sake of our webinar here. But this is the situation where we have Charlotte who has 10 flowers. Some of them are red and the rest are yellow. How many of each color might she have? So first we would want to talk about what does the equation look like with this? And really it looks like she has some red and she has some yellow, and all together she has 10, right? So then we can use the manipulatives to help make sense of that equation. So we can just bring these out, and if I'm using physical objects, the kids can put some yellow and some red in there. Here I have the manipulatives, but I can take a look at changing this if I need to. So maybe I wanted to have 9 yellows and 1 red. So the kids could come up here and they could say, okay, I have 9 plus 1 equals 10, right? And then we could take a look at, there's another possibility. We could have 8 plus 2 equals 10, and they can write that down. We can have 7 plus 3 equals 10, and write that down. So the kids can come up with all the different number pairs that add to 10. Now, right here, I'm doing this in a very systematic way. Very often with the students, it's going to be much more random, right? They're going to do 5 and 5, then they're going to do 2 and 8, then they're going to do 3 and 7. So it's okay if it's random at first. But the whole point here is just being able to see that variance, to see that as one add-in increases, the other add-in decreases. And having the physical tools really makes a difference. Now, one thing I have found with students of all ages, I'm specifically talking with students in the younger years right now, is it can be really helpful to do side-by-side math with this, where one student has the physical tools and the other student has a whiteboard and a marker, and they're doing this at the same time. They're coordinating their efforts. They're also talking about this as they're building the equation. So one student is building the equation with the manipulatives, and right next to them, someone is recording it at the same time on a whiteboard with a marker. Something else that I think is really powerful is to help students also see that relationship between what's happening on the screen right now with the virtual manipulatives next to using the physical manipulatives. So you can also have one student working on a tablet and another student working with physical tools to build the equation so they can see how interconnected these visuals are to using the physical tools. So that's just one example of how you can help students build the equation, making that direct connection from the symbolic to the physical, and in this case, the visual. And so from there, we're going to switch to another strategy, and that is building a word problem. Sarah, could you put up the next slide, the build the word problem slide up on the board? And the write a word problem is another strategy that we have found to be super helpful for our students to help them make those connections. Remember that diagram that Sarah showed at the beginning, it's the arrows that really do make the biggest difference. And so when we have students write a word problem, there's a couple of different ways we can go with this. So when we have them writing a word problem, you can give them an equation and literally have them write a word problem that has the structure and the syntax of a word problem, where you have the prompt with the information, and then you ask a question. And I have to teach the kids, you never give away the answer to the question when you're writing a word problem. So that would be more of a traditional write a word problem. What I'm about to show you now is using the same strategy, and I call it headline news, where I'm not necessarily looking for the structure and the syntax of a word problem, but really are the kids making sense of the equation that they've given to them. So Sarah, if I could have the share feature back. And what I'd like to share with you now is just another Brainingcamp example where I have our build a word problem idea. And what this is going to show you is just a simple headline that I give to students. So the first thing I give to the students is a headline that is an equation. And so as you can see, my screen is taking its time getting up. But the headline I might give to the kids is 3 + 4 = 7. Right? And so the kids are going to take a look at how do I make sense of 3 + 4 = 7. So this is what they would get at first. They would just get the headline, 3 + 4 = 7. Now down below, I wrote what a student said. This is a real true story that I did with kids. And they might say something like this. Yesterday, my dog had 3 puppies and my neighbor's dog had 4 puppies. So in a few weeks, we're going to have 7 adorable puppies playing together in our front yard. So verbally, that's what they gave me, but I also want to see what that looks like. So I asked them to show me their thinking after they've written their story. So they might use something like Cuisinart rods here. Here we have 3 puppies plus 4 puppies gives me a total of 7 adorable puppies. So they can use the tools to really make sense of that headline news story that they created. But let me tell you the rest of the story. I was doing this with 3rd graders, and towards the beginning of the year, we were just teaching them the headline news idea to connect these ideas of writing a word problem that goes along with the tools. And I had given them 3 + 4 = 7 just as an opening. And then here's what happens is later in the year, I actually gave them the headline of 3 × 4 = 12. And they had been working with the manipulatives already. They had been playing around with manipulatives. They knew how to make 3 groups of 4 or 4 groups of 3. The total was 12. So they've been working with them. But then I asked them to write me a news story. And I got a news story that was something like this. Yesterday, my dog had 3 puppies and my neighbor's dog had 4 puppies. In a few weeks, we are going to have 12 adorable puppies playing in the front yard. And so they actually had said there were 12. They knew that 3 × 4 was 12 when we'd been working with it with physical tools. But when they had to make sense of that headline with context, I could tell they were missing something. They were missing a full understanding of the factors, right? Because for them, they were still thinking that the factors do the same thing, like add-ins do the same thing. And so I found that it was really important to add this notion of the visual or the physical tool, because back here when we had 3 + 4, we had 3 of something and we had 4 of something. They behaved the same way for a total of 7. But the students weren't clearly getting that when we added context. So what we had to go back and do was add the manipulatives to the idea of context, so the kids were truly seeing we do have three of something, but it's three groups of four, right? That gives us a total of 12. And so the kids ended up writing completely different stories because the story that they had chosen here lent itself to addition rather than to multiplication. And so it gave us this great opportunity to talk about the way that you design context matters, and it can reveal your understanding of how the kids understand the operations. So this was just a really powerful tool to use to help the kids go from additive thinking to multiplicative thinking in the context of using story and real world examples combined with the physical tools. So I think, Sarah, you have another example for us, right? From the upper
I
grade?
do. I do. And I want to echo as I transition what Kim said about having the importance of having the visual. It's very easy for a third grader to confuse the addition symbol and the multiplication symbol. They look almost the same. They're not necessarily drilled down into which is which and attending at that level of detail with the two different symbols yet. And the visual really shows how they're different in a way that is hard to do with words. And it's particularly powerful, I think, because Kim chose an example where she used the same values. It was still 3 and 4. So I had to have to think about what's happening here. And for that 3 times 4 equals 12, if I want to go even further, is that 3 dogs in the neighborhood each had 4 puppies this week? Or is that 4 dogs in the neighborhood each had 3 puppies this week? There are conventions about the order for multiplication. The US uses a different one from the rest of the world. I'm not sure how many global friends we have with us today. I've always thought if a child in context writes the story, 4 dogs each had 3 puppies. I don't feel strongly about whether they write it as 3 times 4 or 4 times 3, as long as they understand what's happening in the context of the story. Naked numbers, we need a convention. But when it has context, all is good. I'm going to scale this same idea up a little bit and think about division of fractions, because when we think about pain in math class, division of fractions is one of those moments. As Kim said, write a word problem doesn't have to be write a narrative, formal syntax and structure word problem like you would see on an assessment or in a textbook and things. It's describe a situation. It's give me a context for this. I have learned that for me, at least, it's very helpful to give students all of the values as I've modeled here. 3 divided by 1/2 equals 6. Because I want them to think about how do these numbers relate to each other, not what's the answer. And if I put up 3 divided by 1/2 equals something, write a problem, I'm going to have some kids, thank you, John Sangiovanni from a week or two ago, number plucking. Well, I can just keep, change, flip. Or ours is not to reason why, just invert and multiply, or whatever your rhyme is. What I want kids to do is think, what does it mean to say that 3 divided by 1/2 is 6? Where would I do that? What's a context in which that might happen? And then how do I model it? So if I think about context, and you all are welcome to chime in with some in the chat here, the fundamental narrative way I read this sentence is, how many 1/2s are there in 3? There are 6 1/2s in 3. How do I know that? Well, here's a whole, and I actually have 3 of them. Zoomed in a little too far. Slide myself over a bit. And I want to know how many 1/2s are there. Well, there's 1, 2, 3, 4, 5, 6. That's what that equation means. And I'm seeing an example, I think, from Sharon about I need 3 cups of flour, but I lost my 1 cup measure. I only have a half cup. How many scoops do I need? Or the 1 cup measure is dirty because I already used it to measure honey or some other sticky something. If students can think about that, that helps them understand what's going on. And it makes this equation no longer naked numbers. I don't have to worry at this point about what kind of division is this. Is it measurement division? Those sorts of things, partitive, quotative, those ideas. I just want to give kids a mental image of when you see a division problem, how many of this are in that? How many 1/2s are there in 3? So that I can reason about, wait a minute, there are going to be 2 1/2s in 1. Because the other thing I like to do with a problem like this is ask kids if they are trying to compute, say it's going to be more than 1 or less than 1 or about 1. It's going to be about 1 if those 2 values are the same. And then more or less depending on the relationship between them. And that's a big idea to understand what's happening. So 3 divided by 1/2, wait a minute, there are 2 1/2s in 1. So it's going to be a bunch more than 1. It's going to be a bunch more than 2. And I can go on as I get better at the arithmetic. But I need to think about that. And then I can use this goes into idea. How many 1/2s are there in 3 with candy bars, with cookies, with food math, kitchen math. It's all that we do. Serving size, if I'm making granola or trail mix and I have half cup measures and 3 cups total, how many kids can I serve? All of those sorts of things. I'm making bows and I need a 1/2 yard of ribbon for each bow and I have 3 yards of ribbon. How many bows can I make? When kids have that context, it lets them take a naked number problem that shows up on a test and mentally, this is the thinking they can carry with them, say, okay, that could be about the ribbon. That could be about the trail mix or the flour or the chocolate or the cookies or whatever example resonated. And how do I think about it that way? I might not have fraction tiles or a virtual version in my classroom, but I do have this mental image of sketch a number line 1, 2, 3, and then divide each part in half. I have all of these different tools that I've built by making these connections. Oh, Ryan, thank you for a non-kitchen example. That's always helpful. And Kim, yeah, they're creating the problem. Let me circle back to something I said at the beginning just to finish that thought because I think I got sidetracked. I like giving kids the whole equation because if you just say write a word problem that involves 3 divided by 1/2, sometimes you get a narrative that might have 3 and 1/2 in it, but it's not really a problem that meets the purpose. Here, if I have the full equation, it constrains what the kids are doing, and I find that's more successful. So lots of ideas here, and I hope that what Kim and I have done in the last little bit is give you a few examples of what this can look like in a classroom. If you look through the books, you will see lots and lots of examples of all of these, lots of different manipulatives, lots of different mathematical concepts. We tried to cover the range. And the big emphasis of this is, let me jump back to a different slide for a moment. I'll go back to this one. Not the strategies themselves, it's the idea that when you're using one of these strategies, you're connecting the representations. So my naked number equation was symbolic. I made it concrete when I used my fraction bars. I gave it a context when I said this is about cooking. I had to be able to read it out loud and know that I could say 3 divided by 1/2, or how many 1/2s are there in 3. I could connect it to a visual in terms of, if I'm doing the flour thing, I might have my 3 cups of flour and a 1/2 cup scoop. How many am I using? Look at all of the connections students are making as they do this work. That's where the learning happens. And that's the really powerful part of this. And, Kim and I haven't begun to take advantage in this session of all of what digital tools let us do. They give us an infinite supply of things. My 3 divided by 1/2, I didn't have to worry about how many sets of fraction bars do I need to put together to have enough. It's right there. We didn't do a lot of writing on the screen. Kim annotated some beginning her list of equations, but in a classroom, when you're not writing with a trackpad or a mouse, you're probably going to do a lot more of that. Screenshot it, save it. But think as you work with your students, it's not simply, here's how to use manipulatives to model division of dividing a whole number by a unit fraction, my 3 divided by 1/2, because that's still very procedural. It's how do we help children find contexts that are real in their world? With my publisher hat on, we can't come up with contexts that are realistic for everybody. We try to get a good range, but we can't do it. So this gives kids an opportunity to find theirs. It gives them an opportunity to say, I'm really a visual person and I like building these models and making these sketches. And it makes that okay, so that students carry that toolkit around with them as they're teaching all the time. And there is, as Sasha's saying, a lot of reasoning and justification and talking here, because learning does not happen in a vacuum. And I look back on my own experience as a math student, where I sat quietly at my desk doing my worksheets, and I could memorize pretty well, so I got the answers right. And then I got sent to the principal's office for asking why too often, and that was disrespectful, and I didn't get it. And that's not the world we want for our students today. We want them to have lots of tools and toys and options. And that's a lovely daydreaming thought. And then there's the reality of school started last week or next week, or maybe a month away for those of you who are in post-Labor Day parts of the world. But for a lot of folks, it's now. And so I'm going to hand this back to Kim to remind us of some of the practical, how do we get started with this work?
So yes, Sarah and I have worked with many, many teachers across the US and beyond. And it seems that when it comes to using manipulatives, we have general consensus that it's a really good idea. We have general consensus that we know kids need to make sense of their thinking, and manipulatives help us do two things. They help our kids communicate the thinking that's happening, and they can help facilitate brand new thinking. And there are some things that can get in the way when it comes to using manipulatives that we just want to address, because we want to make sure that, Sarah, could you put that back up for me, please? We want to make sure that our kids are really accessing the experiences. And so we do have 3 things that we wanted to share with you that might help you get started, and since it is the beginning of the school year. So the first thing we wanted to say is that it is really helpful for your kids management-wise if you introduce manipulatives one at a time. So for example, let's say at the very beginning of the year, I'm going to be using 2 color counters. So I have buckets for every table, right? And so I will just put a bag of 2 color counters in every bucket, and we'll spend some time exploring those. There's a whole process. There's a blog post on this on the Corwin website on how to introduce manipulatives. I'm having a conversation about, okay, with these 2 color counters, what does it look like to be playful with them? and what does it look like to be purposeful. And so we just introduced this one manipulative. We talk about being playful, and you can be playful with it on your own time on Fun Friday or during your free time. So this is what it looks like to be playful. But in math class, we're purposeful. And this is what it looks like to use these to build equations and to build numbers and to show your thinking and to communicate your thinking. And so that becomes a management tool that we can continue to use throughout the year. If somebody gets playful during math class, like maybe we're using the snap cubes inappropriately or the Cuisinart rods, we can just say, hey, we're being purposeful during math class. That's something you can do on your own time. But we just introduce one manipulative at a time, use the purposeful versus playful model. And then a couple of weeks later, we might introduce the next manipulative, maybe pattern blocks. Then a couple of weeks later, we might introduce algebra tiles or base 10 pieces. A few weeks later, we might introduce fraction pieces. So over the course of time, we have a whole toolkit so that the kids can choose which tool to use, which appropriate tool to use strategically, but they don't get overwhelmed with having too many things all at once. And as you introduce each one, continuing, thanks, Kristen, I'm glad you guys like that, Sasha too, continue to use this playful versus purposeful language. I used to use toys versus tools all the time. And when I said toys, I meant that was a bad thing, don't do this. And then I realized, there's a place to be playful with these. I want kids to have a chance to be playful with the snap cubes because eventually we're going to be using them for volume, or we're going to be using them to show number pairs that add to a specified amount. So I want them to understand those properties and have a chance to be playful as well. And then finally, the third thing that we would like to just introduce you to, there's a blog post on this one as well, is side-by-side math, which I mentioned earlier, where you have one student using the physical tools and another student who has a whiteboard and a marker, and they are going together, coordinating their efforts step by step so that they can see this translation from the manipulative to the abstract, to the symbols. Or they could be drawing a picture. This could be a number line while we're using the manipulatives. Or this could be the manipulatives, and next to it could be the tablet where we're doing visuals. So we just want kids to be able to make those connections in side-by-side math, and it works best if it's 2 students, not 3. I know we have some building thinking classrooms folks out there, and we know that groups of 3 is great. But for this purpose, side-by-side with 2 students is really helpful because it's not upside down for anyone, and they're able to coordinate their efforts. So those are just some beginning of the year tips for you. You can see in the chat box that we have the blog posts linked, and I think we have the other ideas linked in here. So yeah, that's all we have for you today. Sarah, do you have any final ideas to share?
Only an apology that Zoom's apparently in a mood for me today. I didn't mean to keep leaving and not sharing. No, Kim, this is really helpful thinking about how do we get kids started and keep teachers sane, because we got a lot to do and there's a lot going on. So we hope we've given you some ideas for making that move forward and productive.
Mm-hmm. So yeah, everybody, just have a great start of the year. And let's make math meaningful by using manipulatives and visuals and helping kids really engage in the thinking and the understanding as they're making sense of math.
Yeah. So I'll stop sharing and Mark, let you come back up if there are questions we missed or.